This is the law of universal gravitation, gravitational force, example number 2. And it says the gravitational force, or the force of attraction between the Earth and the Sun, again, is 1.6 times 10 to the 23rd. So we have the same force, 1.6 times 10 to the 23rd newtons. We once again still have that distance between the two objects, and we know that the mass of the Earth is me and the mass of the Sun is ms. Our proportionality we had was the force is proportional to the mass of the Earth times the mass of the Sun, all divided by the distance between them squared. And in this problem, what they want us to do is, instead of doubling one of the masses, they're going to have us double the distance between the two objects. So basically I could just take my Sun and move it this way a little bit. I could take my Earth and move it this way a little bit. Now I've basically, or essentially, doubled the distance between the two. So this would be my original distance, and this is my new distance, or my final distance. Let's do that in the problem itself. Let's just say that the mass of the Earth and the mass of the Sun don't change, and so this is the original. Our new force will be proportional to the mass of the Earth times the mass of the Sun, all over. Now our distance, if we made this distance 1, then we could make the new distance 2, because it would be double the distance. So 2 times the distance squared, and we have to square both things. We then would find out that we end up with the new force is proportional to the mass of the Earth over the mass of the Sun times the mass of the Sun, all divided by 4 times the distance squared. So we see that the new force, essentially, since this part right here is the same as what we had originally, we can say that this would be the original force divided by 4. All we did was substituted in this original force on the top, and then we had a new number of 4 down on the bottom, and you'll see that right there. If we plug all our numbers in, the new force will be equal to the 1.6 times 10 to the 23rd newtons, and then we need to divide that force by 4, and we end up with 4 times 10 to the 22nd newtons. And that's what would happen to the forces. It would go down by a factor of 4.